But here in the kitchen, where there is so much stainless steel, its attractive appearance and ease of cleaning is taken for granted. Hey, there's no need to polish that tub. It's stainless steel. Though she doesn't know it, there's quite a history to that tub. And it all began when a well-known maker of home laundry equipment decided that the time had come to adopt stainless steel for this application. To look into the problems involved, one of our area representatives invited the client to our head office in Sheffield. Firth Vickers have branch sales offices throughout Britain, each staffed by teams of representatives who maintain close liaison with pressing operations. Another is a new welding technique capable of attaching studs or similar fasteners to very thin sheet without disfiguring the other side. In new uses such as motorcar bumpers, design receives the fullest consideration. Close collaboration also takes place between our technical liaison team and companies dealing in specialized equipment. One example is the use of high-frequency induction equipment, specifically designed for the softening of deep-drawn components. The process is automatically controlled and is rapid and economical. Heating can be confined to local areas if required, and only the lightest of discoloration occurs on the surface of the metal. Our technical service is backed by comprehensive research laboratories, the laboratories where, in fact, stainless steel was first discovered in 1913 and subsequently developed, since which time a vast wealth of experience has been accumulated. Just as stainless steel has progressed, so has laboratory equipment. Microscopic examination, for example, is now aided by the electron microscope. Similarly, in the testing of heat-resisting steels, this thermobalance automatically records the change in weight of the test specimen as the experiment progresses. Research into high-strength materials is continually in progress. In addition to room temperature tests, facilities for sub-zero and high-temperature testing are also available. Greater demands, too, have been imposed upon analytical methods. New melting techniques have made possible stainless steels with carbon contents less than 0.03%. This, then, is the organization which created stainless steel and provides the basic knowledge that enables these engineers and technicians to adapt it to a washing machine tub. The grade of material has been chosen, in this case, Staybrite FST steel type 302, and design modifications are being suggested to simplify manufacture and make the most economical use of the metal. In the customer's factory, much work now lies ahead, with the making of prototype tubs the first objective. A combination of pressing and welding has been decided on as the method of fabrication. This, together with the high-strength characteristics of our Staybrite stainless steels, permits the economical use of thin-gauge sheet and strip. The whole project now becomes a concerted team effort, and the production engineer and his staff quickly learn the characteristics of the material, and you will see how effectively they adapt standard equipment to suit it. Staybrite stainless steels, although extremely ductile, are also very tough. In press work, therefore, high holding down pressures are required. Otherwise, this occurs. In the case of a single-action mechanical press, greater restraint is put on the blank by increasing the pressure on the air cushion. The pressing of the base of the tub is not in any sense a deep drawing operation. It does, however, involve, during this first operation, a wide flange which will subsequently form the base of the tub surrounding the agitator. It is essential, therefore, that the flange be kept flat and free from any surface damage. You will have noticed that a square of brown paper is placed under the blank for the first stage pressing. It was found that such a procedure on this particular press gave the consistent high standard of pressing required. The excellent surface finish of the blank has been maintained, and wrinkling prevented. This then is the base of the tub, produced on a medium-powered single-action press. For full-scale production, it was decided to use material for this project in the form of blanks in order to reduce handling. However, if required, we could equally well have supplied either sheets or coils up to 5.5 tons in weight. Let us now look at the production of the other part of the tub, the main body or wrapper. The strip is first trimmed under a blanking tool to give the dimensional and edge accuracy necessary for the subsequent butt weld. Again, the blanks are brought to the machine in the packing case. The wrapper of the tub is formed by automatic arc welding, a technique which can be applied to very thin material, in this case 0.022 inches, and produces a neat, smooth weld which need not be ground or polished. Assistance on the design of the jigging arrangement was received from the aircraft industry, but the actual manufacture was carried out entirely in the customer's own workshop. Care in jigging is of paramount importance, as the edges must butt together perfectly. It is for this reason that a prior blanking operation, as you have seen, is introduced. Should there be any misalignment of the edges, this is the type of weld defect that can occur. The production personnel quickly devised a fixture to ensure precise location of one edge. It is then simple to position the other edge correctly. This automatic setup was not achieved without considerable time and effort, but it is a rapid and economical method of making a joint that needs no further attention. A weld runoff tab is used to avoid any imperfection at the edge of the wrapper. The two parts of the tub have now been formed, but a few operations, mainly the punching of holes, are still necessary before the two are joined together. Being a bulky object, the wrapper could present a floor space problem if storage were necessary. With stainless steel, however, this problem is eliminated, as no finishing treatments whatsoever are necessary. The stainless steel manufacturer provides the properties and surface finish required. This production layout covers a floor space of approximately 70 square yards and is capable of producing 3,000 tubs per week. The final operation is the resistant seam welding of the wrapper to the base. Like all the previous operations, this is carried out on standard equipment. The finished tub is fitted into the unit, ready for final testing and inspection. It will give a lifetime of trouble-free service and completes, in every sense, a washing machine designed to meet the needs of the discerning housewife. Quantity production of washing machine tubs, fabricated from stainless steel sheet, calls for large-scale production capacity by the steel manufacturer. A short tour of the continuous sheet mills at our subsidiary company, Sheffield Rolling Mills Limited, illustrates our ability to deal with such demands. Slabs 5.5 inches thick are first rolled in a hot reversing mill. This is followed by rolling in a fast hot steckle mill, where, during passes through the rolls, the strip is alternately coiled in reheating furnaces situated at either side of the mill. These furnaces maintain the temperature of the strip necessary to reduce it to 3/16 of an inch in thickness. The stainless steel is now in wide strip form and is coiled ready for further processing. Cold rolling is carried out principally by Zenzimir mills, capable of reducing the strip to very thin gauges with an overall high surface finish. Intermediate softening may be necessary, depending upon the degree of reduction required. Continuous lines are used to deal with this, as well as the final softening and descaling. Finished coils are then transferred to the sheet warehouse. Where customers have facilities for handling coils, these are available in various widths in weights up to 5.5 tons. The coils pass through various stages of inspection before being finally weighed and packed for dispatch. Strip up to 12 inches wide is produced from coil sheet. After slitting, the strip can be further cold rolled in our narrow strip mill. Alternatively, sheet material is available in standard or special sizes. The coil is first fed into a continuous cut-up line which shears it into lengths. These are then passed down a shearing line where the sides and ends are cut square and true. Customers' individual requirements for circles for such items as motor car wheel discs, saucepans, teapots, and of course washing machine tubs, are supplied in a wide range of Staybrite and stainless steels. Throughout the cold rolling operations, particularly in the inspection and dispatch bays of the sheet warehouse, tissue paper is interleaved between all sheet surfaces to protect the fine finish. Finally, the material, whether in coil or in cut sheet form, is carefully packed and prepared for dispatch to customers throughout the world. Whether it is stainless steel for Great Britain or for